Morning, Joe.
Today we'll be starting off with this worksheet, yeah, the one that you all got.
Morning, Joe.
Good morning, Mishana.
Morning.
Sir, I'm not getting the registration. Why?
You just have to click the same link. Click the same link.
Sir, so we joining with last week's one.
Yeah.
But in the email it says that it ended last week already.
No, but we've already renewed it, so you can click the same link and you'll come back.
Oh, okay, sir.
Please have your worksheets with you, yeah, the one that your parents picked up. We'll discuss it today.
Sir, will you be going through the past year paper physics thing?
What past year paper?
The one
thing
that
you gave us.
Huh?
The thing you gave us, Joe, about remember you said do from question 1 to 3.
Oh yeah, after this I discuss this first.
So exam, please don't give IG, Joe.
Huh?
Exam, please don't give IG.
We shall see.
It takes a very strong will not to slit your wrist.
What?
And I'm practicing to strengthen my will every time I do the work.
Well, I'll be okay. And plus, this is MCQ only, what? Should be okay.
So can I explain about the Sankey diagram, because they said how much energy you need per square. I can draw it, but I do not know the specific.
No, that one no need to do like that one, just cross out because we didn't learn that.
Because I didn't draw I did the questions, but I didn't draw the diagram.
No. Each square you don't need to answer that, but drawing the Sankey diagram, you just draw normal. No need to draw it like in.
Precision and all.
No.
Okay.
Okay. I'll simply take attendance, then we will start. Okay. Isaac. Isaac is here. Isabel? No, not here. Abigail?
Here, sir.
Carlos? Elijah?
Yeah.
Ishka? Kanishka?
Here, sir.
Ricardo? Ricardo not here. Jared?
Here, sir.
Celeste? Celeste? Pooja?
Here, sir.
Monica?
Yeah.
Tariq? Michelle? Malcolm? Judy? Just give me a moment.
Sure, Ricardo have doctor's appointment, so he cannot come to class.
Can you ask him to text me, please?
Okay.
So you're in your kitchen, actually.
Yeah. Yep, I'm in the kitchen. I have a table here. Okay, let's start. Okay, let's look at question 1. Okay, I have a kettle using 1200 joules. So 1200 joule is the input energy. I have a kettle. 1200 joule is the input. Electrical. Now, the question says, how much is the useful energy is how much? How much is the useful energy?
900.
900. That is what energy?
Thermal.
And wasted?
300.
300.
And that is in the form of thermal also, heat, but this is lost to the surrounding. So draw a Sankey diagram. Okay. So yeah, just a moment. Can I see, please see all your pictures? Can you show me on the camera? I want to see your diagram.
So for me, I didn't do mine because I didn't know the specifics of it.
Let me see the rest. Now show me in your camera. You can just on your camera. Go far a bit, Jared. Bring your paper far a bit. Okay, thank you. Zarid, okay, never mind. You don't know how to do it. Okay. Sureka, can I see yours?
Sure, I didn't do.
Anyone else did? Who wants to show me their work? No, okay. Let's look at it now. Okay. So we always start with the input energy because that's where the energy is coming from. Okay, so input energy is 1200. So you start off like this. I'm trying to put you all in full screen. Okay. So you start off with 1200 here. Now remember, your useful energy is always the arrow pointing towards the right, and the wasted energy is always the arrow pointing downwards. Whether one is bigger than the other, no matter, even if wasted is much more than useful, it's always down. Wasted is always down, useful is always to the right. And the amount of energy wasted or used will determine the size of the arrow. So if there's more useful energy, then your useful energy's arrow will be bigger and fatter. And then the other one will be smaller. So you have to draw the arrow sizes significantly different. Don't draw one is 5 cm, the other one 6 cm. I cannot see the difference. It must be a big difference. So we start off with 1200. Okay. Electrical energy. And then your useful energy is 900. More, which one is more, used or wasted?
Used.
Useful one. So the useful arrow is going to be bigger. Okay, so this is pointing towards the right. And then my wasted energy will be smaller because it's lesser. So you see, this one is fatter. This one is thinner. And then I must write here 900 joule thermal energy. And then 300 joule of heat energy. This is how you draw your Sankey diagram now. Okay. Please draw. Those who didn't draw, please draw. Remember, your wasted energy is always pointing to the bottom. Whether it's more than useful or not, it's always pointing bottom. Useful is always pointing to the right. Okay, this is known as Sankey diagram.
Sir, do you know the past year paper? Did you check my work already?
I know we will discuss in class. So the ones that I discuss in class, I will only check after class. Since we are going to discuss in class.
But you must still due the paper actually. Like before due, you must still give the paper, right?
Yes.
Okay.
So number 1I, how many joules does each one run down here to do? Just cross out that question. Let's look at number 2. Calculate the efficiency of the kettle. Show your working. So to calculate efficiency, you just use this formula lah. So the formula says useful energy over total input times 100. So in this case, what is the useful energy?
900.
900. What is the total?
1000.
1,200.
1,200, and then I times 100%. Cut. You get 75%. So that is the efficiency of the kettle. So is it considered high or low efficiency?
Hi.
And also because the useful energy is much more than the wasted energy, which means it's more efficient. If you have wasted energy more, then the appliance is not as efficient. Okay, if you're done, those who did not do the Sankey diagram, you can try the next few ones.
Sir, for exam, must we analyze the Sankey diagram or anything?
Yes.
Morning, Miss Shaina.
Okay, let's look at number 2. Number 2, what appliance are we looking at?
A toaster.
Okay. What is the useful energy?
300 joules.
300 joules.
So for a toaster, the 300 joules of useful energy is what form of energy?
Heat.
Thermal energy.
Toaster, and I have 1,500 joules is the input energy, electrical. And then I have 300 is to toast the bread in the form of heat. So if 300 is in the form of heat and it's useful, my wasted is how much?
1,200.
1,200.
1,200 is wasted. Okay. Now, just from these numbers, the wasted is more. So is it a high efficient or low efficient toaster?
Low efficient.
Low efficient. Why? Because
More energy is wasted.
more wasted energy compared to useful energy. So, number one, how much energy is wasted? 1,200. Where does it go to? So, if heat is useful,
Its surroundings.
okay, it can be heat loss to the surroundings. What else?
The sound.
Sound energy.
Yeah, it could be sound energy. And then some places have light indicator. You can go on form of light energy as well. Okay, so it can be either one, like you can choose. Okay, then draw the Sankey diagram for the toaster. Now, which arrow is going to be bigger now, the useful or wasted?
Wasted.
So the one that is pulling it down is going to be much bigger. So the one for useful will be thinner, and then this one will be larger. Okay. So I have 1,005 here. Please draw on electric.
So in the exam, when we draw the Sankey diagram, draw with pencil, right?
Yes. And then 300 joule of heat. And then 1,200 joule will be, can be light, can be sound, or can be heat loss to surrounding one. You can write either one, which one you choose. You see, when I draw, this arrow is significantly bigger than this arrow. So make sure I can see the difference. Okay, don't draw almost the same size or and then tell me, oh, but it's 2 cm bigger. No, make it significant. Okay, and then calculate the efficiency as well. So again, we take the useful divided by the input times 100%. What do you all get for efficiency?
20%.
20%.
Yeah, 20%.
So let's say in the exam when we draw the Sankey diagram, if it looks a bit same, will you minus mark?
Yes, because I need to see a clear difference between the useful and wasted.
Okay, so
If you're done, you can go on to the next question, which is question 3. They asked it slightly differently, but same concept, same formula. So try question 3 first.
So may I go to the toilet?
Yes. So now I have a microwave. It transfers electrical energy into 40 joule of energy to cook food. So now my electrical appliance is a microwave. What is the input energy?
500.
500.
The total energy is 500, sir.
So the 400 is what?
The 400 is the useful energy.
Correct. So 400 is the useful energy. And then to cook food. So to cook food, I need what energy?
Heat.
Okay. So now it says it has an efficiency of 80%. So efficiency, to calculate efficiency, is my useful, in this case 400, over my total input. But I don't know what my input is yet, so I need to calculate. And then times 100%, I should get 80%, because they say efficiency is 80%. So based on that, they're asking how much electrical energy is used in total. So how much is this?
Sir,
Yes.
so what I did was, because the efficiency was 80%, what I did was I put 80% equals 400 joules over X.
Yeah, can also using ratio lah. Can also. Okay. So now
I
400 over x times 100 equals to 80.
did this, sir.
And then I solve linear equation.
I did this.
Ah. Yeah.
Okay, sir.
Just using the formula lah. But yeah, that's and then I should get x equals to 500 joule. That means my total energy at the start is 500 joule. So if 500 joule is total energy, what is my wasted?
100.
100. Okay, so you should get your total input energy as
How do they like calculate how many joules are in a certain device, what apparatus do they use?
Sorry, can you please ask that again?
What apparatus do they use to calculate the energy intake and then the useful and non-useful energy?
So when they calculating for energy, you're taking, so energy is equals to power times time. So for a certain
Wait,
time, how much?
power.
So then you get the amount of energy. And the power of the appliance comes with the appliance itself. So when you buy an appliance, they will tell you how many kilowatt per hour. This is the power that they are referring to.
Okay.
The appliance will have a power, and then over a period of time, then that will give you the energy. So that's how they calculate energy. Okay, so can I erase this? Is anyone still copying this?
To me.
Okay. And then if you're done, you can draw the Sankey diagram. Okay, done? Everyone done?
Done, sure.
Okay, so now draw the Sankey diagram. So which arrow will be bigger?
The waste.
Heat.
Not something like this. If microwave is heat energy is useful, wasted can be what?
Light,
Right?
sound.
But the light is actually necessary. I mean, it's necessary. It's not necessary to cook food, but sometimes people need light to see how the food is being cooked, right?
Yes, but that doesn't help with the cooking of the food.
Oh, okay.
But do you need the light? Yes, you need the light. But does it help with the cooking of the food? No. So that's why it goes under wasted.
So the arrow downwards, it doesn't necessarily have to be curved, right?
No, it can be straight as well.
So can I go to the toilet?
Yes, can.
Done, sir.
Done? Okay. Then let's look at the last one. We're looking at a hair dryer. Okay. Okay, you can start doing since we've already gone through a few examples. So I have hair dryer. My input is 1200. Um, 600 joule to dry hair. 500 of this 600 is used to heat the air. Okay. What are other forms of useful energy? So 600 is useful. Out of the 600, 500 is to heat the air. What else? What are other forms of energy that are useful?
Useful, actually.
Hmm?
Did you say useful or wasted?
Useful. That is the question one. What other forms of useful energy?
Thermal energy.
Thermal energy. Yeah, so that is for to heat the air. What else is useful?
Light. Light energy.
Dry the hair.
There's no light, I guess.
No. Light is not useful, right?
Yeah. Uh, I think that's the only thing.
Kinetic energy.
Okay, so now in the hair dryer, there's a blade. So for the blade to move in order to cause movement of air, there is
Electrical. Okay, no.
Wait, there's a blade inside a hair
Actually,
dryer.
there's
There
okay.
is.
the kinetic energy in form of useful energy. So if 500 is for the heat, how much will be for kinetic energy?
100.
100.
How much energy is transferred for this question too? Is 100. 100 joule is wasted as sound. 100 joule is wasted. If 600 is useful, how much is wasted?
500.
Huh? If 600 is useful here, how much is wasted here?
600.
And then it says 100 joule is sound. Okay. What is other form of wasted energy?
A light. GPE.
So is there light in hairdryer?
GPE je.
Uncle told us.
GPE ke nak?
GPE.
Yeah.
Gravitational.
Why GPE? Where is the GPE coming from?
I mean, if you when you hold when you hold it up at a certain height, there's also gravitational potential energy affecting it, right? But it's not useful, lah.
Correct. But okay, let's say the hair dryer, I don't lift it up. Let's say I'm drying the carpet. Then it's on the floor. What?
There's still gravity acting on it, right? Jay? Otherwise, it will float.
No.
Huh? Sorry, say that again.
There is still gravity acting on it. Otherwise, it would start to float.
Correct. But it's at the lowest point, what? To the floor, to the ground. Only when it comes from a certain position up from the ground, only then there's GPE.
Yeah, but even at the floor, you can still see some form of energy acting on it, because if you on the hair dryer and leave it there, that it's not going to stay still. It's going to move about a bit. At least it might even vibrate.
But that is not a significant amount of energy, lah. There is sound. Sound is one of it, and then there is light energy. But GPE is not significant enough.
Nuclear energy.
Nuclear? No, nuclear, no.
Sound.
Sound, yeah, sound 100, and then 500 joule.
Heat to surroundings.
Huh?
Heat to surroundings.
Okay, and then draw the Sankey diagram. Now, in this case, right, 600, 600, what is the efficiency without calculation?
50%.
Okay, so in this case, because useful and wasted is same amount, so in this case, your arrow will be the same, same size, both for useful and wasted. This one can be same size. Yeah.
So for the II is 100, right?
Yes. Okay? Everyone done? Okay, you all can go and take a 10-minute break and then we'll come back and continue. Okay?
We have a
I
30
haven't
minute
finished
break.
copying.
What? Then might as well we need to come back now. 10 minutes. 10 minutes. Okay? Come back in 10 minutes. Anyone still copying?
Nature.
Come back by 10. Share screen now. This one correct? This is the questions, right?
Yeah, sure.
Yes, sure.
Yeah.
Yeah. Vishina?
Yes. Can you hear me?
Yeah, so after exam, we finish on the 3rd, right? That's a Friday. Then from the 6th onwards, we have a 1 week holiday, right? Okay.
So only 1 week.
Should give at least 2 weeks, Ajay.
Please, please.
Yeah, we really need 2 weeks.
I mean, so far we were told that 1 week lah. If you all want more, then I don't know, maybe you all can ask for that. I don't know, we were told 1 week, but feel free to ask for more.
Have you ever dived in the Great Barrier Reef?
You want to die in the Great Barrier Reef?
No, have you ever dived? Like, have you ever went diving in the Great Barrier?
I've never dived there, I've only snorkeled there. But
Wow.
I got my diving license after that.
Oh.
So after this midterm exam, you concentrate on finals, right?
Sorry, ask again? Say again?
After this midterm exam, right? After the 1 week holiday, then we concentrate on finals.
Yeah, we have finals after that lah.
No,
So
after
will
the
we
1
go
week
back
holiday,
to school any sooner?
I don't know lah. So far only the older kids are allowed to come back to school. So y'all, I don't know yet lah. I really don't know.
that means are they in school now?
No, next week Wednesday onwards, because the government only allowed next week Wednesday onwards. So from next week Wednesday lah, they will be in school. They also having exams, so they'll have exam in school lah. But only Isaka class. Yeah, the rest still cannot come back now. And they come back also, they have to still sit like 1 meter apart and all that. They can't sit like normally. Okay, so let's look at these questions. Okay, so I have a padding pool and it is filled with seawater. The volume of the seawater is 264. What is the depth? What did you all get?
0.3 meters.
I got 0.3 meters.
Yeah, so you should
0.3 or so.
yes, you get 0.3. You can mark your or I will write the answers on the board. Okay, y'all mark. So far, okay? All got these answers up.
Yeah, sure.
Sure. For 1C, I got 3068
What's that?
pascals, sure.
Yes. So this is the rounded off answer lah. What's your answer?
I got 3068.
Yeah, same, sir.
How is your working?
It is the pressure times density times gravity, so it's 0.3 times 1022 times 7.727 times 10.
Shah?
So mine 0.3 times 10.2727273 times 10.
Yeah.
So you know for B, right? The 1022.727273. Is it okay if I make it 0.22.7?
Can. Can. Usually this answer is the rounded off answer lah. But you should get between 3058, 3060, around there. Did y'all get that?
Mm-hmm.
Yeah? Okay. And then we look at number 2. I told you to do 1, 2, and 3, right?
Yeah.
Yeah, sure.
So for number can you know my answer, Joe?
For number 2, is it? 2A.
Yeah. 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 For condition 1, I wrote the effort and load have to have the same mass and they must be in an equal distance from the pivot.
Yes. So not same mass, same force.
Is it what?
Sure.
But yeah, that's correct. Yes.
Sure, I wrote the effort must be equal to the load. Is it okay?
But you must also say that it must be same distance from the pivot. Because if it's not same distance from the pivot, it won't be equal. It won't be equilibrium. So you must add there and say that it has to be equidistant from the pivot.
So I read the condition too, Acha.
Okay?
If the distance to the pivot and mass are different, the effort and load must be at different distances from the pivot.
Can you read that again, please?
If the distance to the pivot and mass are different and force are different, the effort and load must be in different distances from the pivot.
Okay. Okay, I understand what you're saying. Okay.
Sure, for my condition too, I wrote if on water the weight and upthrust must be equal. Is it okay?
I thought upthrust is only for water.
Yeah,
Yeah,
this
the upthrust and weight must be equal. Can I sure?
if you say for water, okay lah. If you must put there for water lah. Okay. Other things that you can say is the clockwise moment must equal to the anti-clockwise moment. And then you can say no resultant force. Or you can say forces are balanced. Okay, these are things that you can say lah. Let me just write that on the board. So there are many conditions, many ways you can write it. You can also say
Is what I said correct?
sorry?
Is what I said correct?
Sorry, I can't hear you. Say that again.
Is what I said for B correct?
Yeah, correct. Okay. This is one, or you can say resultant force is 0. What was yours, Elijah? Read out yours, the first one.
The first one, 2A. Okay, so for condition 1, I said the effort and load have to have the same force and they must be in an equal distance from the pivot.
Must have the same force and are of equal distance from the pivot. Okay. Jared, what was your second condition? The water one?
If on water, the weight and upthrust must be equal.
Just so you
So
can
for the first one, you wrote anti-clockwise moment must equal to the anti-clockwise.
Sorry.
Clockwise?
just so you can choose either two and right.
Yeah. Any two?
So don't resist actually, I'm writing it.
Done, sure.
Sorry? Elijah, what did you say?
Don't erase it, I'm writing it down.
Oh, okay. Yeah, can.
So what do you mean by resultant force is on? Huh?
Is 0. Zero Newton. That means no resultant force.
So you said if you ask us to calculate pressure in the liquid, the gravitational is always 10, right?
Unless they state otherwise, unless they give you, sometimes they give you values like 9.8, then you use that. If they don't state any value, then you use 10.
10 is for in any liquid.
Yeah. On Earth,
Why,
the acceleration. On Earth, the gravitational acceleration is 10. That's value.
But on other planets, it would be much higher, like in Jupiter, and be much higher.
Be different lah.
Sure, when will you give out the live interview questions?
I don't know, what does the email say?
It'll be given.
What does the email say? You all got the email ready, right? I don't know.
It didn't set a date.
It didn't say a date. What does it say?
It just said given a week before.
Okay, then a week before, 7 days before that. I'm not sure because I don't have the email. I didn't see the email. Only you all have the email. Okay, let's look at B. I have a meter ruler PQ in equilibrium. The distance PQ is 100 cm. It means from one end to the other end is 100 cm. The mass of the meter ruler is 0.12 kg and its weight is W. Okay. On figure 2.1, draw and label an arrow to show the force W acting on PQ at the center of mass. So where would that be? So if this whole thing is 100, where would the middle be?
50.
Huh? 50. So
At
50
50.
here. Because 10 and 40 is 50. So your weight must act downwards here. So you must put an arrow down here with W. Let's see if I can do that.
Sure, can explain again, Ajay.
So this whole thing is 100 cm, the whole ruler. It says draw an arrow to show W acting on PQ at the center of mass. The center of mass means in the center of this. So if 100 means center is 50, so 10 plus 40 is 50, and W is here. Because it says that the weight of the ruler is 0.12. So weight is acting in the middle, downwards. And then an arrow to show the force R acting on PQ at the pivot. Okay?
Sure.
Yes.
What's the space-time continuum? Huh?
Sorry?
What's the space-time continuum?
I don't know lah. I have to Google it up.
So, question B number 2, I'm not so sure.
B, you mean part 2?
Yeah.
So it just says an arrow to show force R acting on PQ at the pivot. So the pivot is here. So the force R acting on it will be upwards lah, and then you label it R. That's all. Because it says at the pivot one. That's all. So W is downwards, R is upwards. Okay, all okay?
Okay, sure.
Okay, the next one, 2B2. Okay. By taking moments about the pivot, calculate F. What did you all get?
I got 0.05 Newton meters.
0.05.
Oh, yeah. For the left side, I got 0.05 Newton meter. On the right side, I have no idea. And calculate R, I completely didn't do. I don't understand.
Okay, let's see. By taking moments about the pivot, calculate F. So F is here. So moments is force times particular distance from the pivot. So I have it down. Let me just take down some values so that we can do this on the board. And then my weight. Okay. So I've drawn the picture here roughly. So this is 50 meter. This is 10. This is 40. So on the right hand side, what's the question asking? The question is asking, calculate F. So I need to calculate F. Okay. See here. Okay, so we know that the upward, so my downward force is 0.12 kg, which is 1.2 Newton. Okay, I just times 10 kg to Newton. I just times my gravitational acceleration. I get 1.2 Newton. So acting downwards is 1.2 Newton. Okay. Now,
Okay.
This is for the right side, actually.
so this is for downward because the weight is 0.12 kg according to the question.
Really?
Question. It says here, the mass of the meter ruler is 0.12 kg and its weight is W. So 0.12 kg is the mass, the weight is 1.2 lah. Okay. So, let's see. How do we do this? 0.5.
Sure, my working was 0.5 times 0.1 equals force times 0.9.
Why 0.1 now?
Because isn't it 0.1 meters? Because it's 10, yeah, because it's 10 cm, so we convert it to meters, right?
I thought it was meters. So I take 0.5 because moment is force times perpendicular distance gives me the moment. So
Sure, can you see my working?
huh?
Can you see my working whether it's okay or not?
What do you get?
I get 0.05 Newton meter.
Okay, let me check. I also have to do. Moment is force times distance. So for this side, it is 0.5 times 0.1. Because 10 cm I changed to 0.1 meter.
Then it'll be equal to force times 0.9, right?
This one.
Because it's 90 cm, right, sir? So you convert it to meters, it's 0.9.
Wait, Jojo, what's that? M equals F times D. I mean, that's mass equals
No.
force times.
Moment.
Oh, so So yeah, that the 0.05 Newton meter is for the right side, right?
Left. 0.5 times.
Yeah,
Left.
left. That's what I got for the left.
So
But for the right, I don't know how to calculate because I do not know.
force times
Sure. Sure. Isn't right and left the same? Because it's in equilibrium, sure.
Oh yeah.
let me just write.
Yeah. Yes. So both
Sure.
forces will be the same.
I think Jared is correct sir, because the question says it's in an equilibrium, right?
Okay, yeah.
Yeah. Yeah.
That means both the force equals lah, so resultant force is cancelled out.
Yeah. Exactly. So basically, so my other working was F equals 0.5 times 0.1 over 0.9, and then I get at the end I get 0.05 Newton meter.
Yeah,
Put them to each other. So my force will be. Is that what you said?
Yeah, sure.
where does the 0.9 come from? Huh?
That?
90 cm, but so we covered it to meters.
Oh, okay.
90 cm. Let me just double check.
So can we copy that?
Then, okay, do you all know what's happening here, the rest of you? I'm just equating the left side moment to the right side moment because they are equal. So the left side moment is equal to right side moment. Left side moment is force times times distance from the pivot. So for left side is force times the distance, which is 0.1. 10 cm I change to 0.1. For right hand side, I don't know what's my force. Okay, but I know that my distance is 90 cm, which is 0.9. Then I just equate the left hand side with the right hand side. But if it's equal, if it's equal, it's different, you know. Because now this is not moving left or right.
Sorry, can you say it again, please?
Wait, I don't copy it,
Wait, I just copied it.
Now it's equilibrium. So equilibrium means this is not going to turn anti-clockwise or clockwise. It's going to stay the same. It's going to be equal. Remember the Star Wars? The Star Wars.
Wait, I think the force cannot be the same, because you can be at different distances from the pivot and still have an equilibrium. It's not necessary that you must have the same force. It depends on your distance to the pivot also.
Correct. So because this is in equilibrium, it's not a seesaw like the Star Wars lesson. So it cannot be right is equal to left. Because this is in equilibrium.
So this one correct, right?
Which one?
Not sure.
Which one is correct? Which one are you asking about?
Not sure because teacher said wait first, don't copy first.
Oh no, let me just look at it again. Let me try a different method. Let's say I say up moment is equals to down moment. Then up moment is the moment of P and F. And then I equate that to the down moment, which is W. So my up moment is 0.5 times 0.1, that's for P, plus with moment of F, which is 0.9 times whatever the force is. And that is the weight. Yes?
Can you go back and see how you got P plus F equals W?
Oh, so now instead of equating left to right, I'm equating the top to the bottom. So the top is P and F, and the bottom is W.
Yeah.
So P and F, when I add them together, must equal to the bottom. So I'm trying this way first.
You should just invent a new formula, Acha.
Huh?
Did you just create a new formula?
No. This is moment of P plus moment of F equals to moment of W. So instead of equating left to right of the moment, I'm equating the moment of the up and the bottom because it's equal. It's equilibrium. So there's no one is bigger than the other. Like during the Star Wars lesson, one side was bigger than the other, so one further gets kicked out. But in this case, it's not, no one is being kicked out because it's equal. So that's why I'm not equating the left to the right. So I'm trying to see if this works or not.
Exam, please don't give questions like this, Acha.
Please, sir.
Yeah. Even if it takes you more than 5 minutes, it's gonna kill us.
For exam, your question will be given earlier, ma.
Wait, so everything is given earlier, lah, so I can check with my tuition teacher and I'll make sure it's perfect and then pass it up, lah.
Up to you, lah. But I will mark you accordingly, lah.
Oh, okay.
I know your lot, so I know if it's your work or not, lah. Anyways, let me try.
Sir, how many theory-based questions are you giving in exam?
I think you have 50 MCQ. So it divided to 3 lah. Theory, calculation, and application. It's a equal division of all 3 lah. I need to think about this question again. I will get back to you on this question. Okay? Because there's a bit of...
Miss Sharna,
Jay, you got a new phone cover, huh?
No?
Miss Sharna.
Yes.
Yeah, I have to leave the class at 10:30 because I have to go to school to take some papers, like some stuff.
Okay.
Okay, thank you, Jen.
Okay.
Bye.
Bye.
Bye, guys.
Jay, can I also leave the class? I have a disorder called mental stress issues.
What? Okay, I will get back to you on question 2. Let's look at question 3. Calculate R. R is the one at the top here. Okay, so if down is 1.2 Newton R has to be, up has to be.
Now did the question, I don't know how to.
Yeah, this one, I did, which is since you mentioned 0.12 kg, right? So
Yes.
that means it's acting, that means if it's in an equilibrium, that means 0.05 Newton. So we already have the left side. So then we, in order to calculate the force acting on the pivot, we must calculate both the moments, right?
No, this is just straightforward. Calculate R. Okay. Now,
Or 10 cm.
no. See, here is, below is, wait a, let me just take a pen. Okay, so below is 1.2 Newton, correct? 0.12 kg is 1.2 Newton, correct?
Yeah.
Okay, and now it is in equilibrium. That means the downward force must equal to the upward force, which means this is also 1.2 Newton. Because R is just the opposite of W. So it's just 1.2 Newton. Because downward force must equal to upward force because it's in equilibrium. So R is 1.2 now. Can you understand? Good.
Wait. So can you explain how you got 1.2 Newton?
Because the weight is 1.2 Newton, the force acting downwards. And because
Okay.
it's equilibrium, the downward force is equal to the upward force.
For it to be in an equilibrium lah.
Yeah. So because R is at the pivot, so it will also be 1.2 Newton lah, but upwards. So that makes it equal. So R is 1.2 Newton. Oh, okay. I know. I figured out how to do the part 2. Okay. Let me just switch that. So now remember when during the Star Wars question, one was bigger than the other and one could kick out the other. So we use anti-clockwise moment equals to clockwise moment. But now this is equilibrium. Okay, and like I said just now, upward force equals to downward force, which means my weight, okay, my weight must equal to my upward. So at the top I have P and F. Okay, and at the bottom is W. So the moment of P is 0.5 times 0.1. And the moment of F is 0.9 times whatever the force is. And what is the moment of W? The force,
1.2 Newton.
what is the distance from the pivot?
40 cm.
0.4.
0.4. So 1.2 times 0.4 is 0.48. And then I want to calculate for F. I do normal linear equation. Okay. So I should get,
So the total answer is 0.477.
0.48 lah.
Is this what the IG answer sheet said?
Yes. Because now we are looking at it is equal. So I cannot take anti-clockwise moment equals to clockwise moment. Okay? Because that will only work if one is up and one is down. In this case, it's equal.
Yeah, but then isn't it if it's equal that means it must be in an equilibrium, right?
Yeah.
If it's staying like that means you can still use the clockwise movement equals the anti-clockwise movement, right?
So
But it's a difference between the length of the pivot, what?
Yeah, but just say the length and the pivot are the same. No, I mean the length and the force is the same. Can't we still use that?
if the length and the force is the same, then okay lah.
Okay.
But in this case, it's different.
So we use this formula lah.
If it's equal, I have P here, okay, and F here. So those are the two forces acting on the ruler, and that must equals to the weight of the force that is acting below. So I equate those. So P and F together will give me W. So I equate both, and then I can find F. Okay.
Sure, is physics your favorite science subject?
I have no favorite science subject lah. I just like maths lah. That's all. Physics is okay lah. Physics is okay. Bio is okay. Yeah.
Did you get a scholarship?
Huh?
Did you get a scholarship to go to Australia?
No, I didn't.
Oh, why did you come back, sir?
Why did I come back lah? I just felt like I needed to come back, so I came back.
Oh, you didn't want to live there.
When I was in my second year, I wanted to live there. But then after that, when I came to my final year, I decided to come back lah.
Oh.
Okay. Let's look at question 3, right? We did question 3, right?
Yeah, sure. I wrote an essay for the first question.
For A, I wrote an essay, but for B, I didn't write anything.
Same lah.
I have a gas contained in a cylinder and filled by a piston. Describe in terms of momentum of the molecules how pressure is exerted on the walls of the cylinder. So describe in terms of momentum of the molecules. Momentum means the movement lah. How is pressure exerted? So now this is gas molecules. What do we know about gas molecules?
Gas molecules are compressible.
Okay, what else? How do they move? What is their movement like?
So I wrote when the piston is pushed against the gas, the particles of the gas become closer together. Because of this, they collide with themselves and the walls of the cylinder more often, therefore increasing the pressure exerted on the walls.
Sure, do you want me to read out mine? Mine is like 15 sentences long,
15 sentences long. I will tell you what are the key points, okay? So now, to answer a question like this, okay, how many points? 3 points. So it says describe in terms of momentum of molecules. So we want to look at the movement of the molecules. The key word is already in the question. So they wanted your answer to have movement of the molecules and how pressure is exerted on the wall. So now, when you push the piston against the gas molecules, now gas molecules, they're always moving, they're always bouncing around, and they're colliding with one another. They're not in a fixed position like solid. So when you push the piston to the gas molecules, they're going to become closer and closer to each other, and they're going to bounce off each other and collide with the walls. So that's the first thing you want to mention. The molecules will collide with the walls. Let me write down here. So that's the first point. Molecules collide with the walls. Okay.
Sure, what happens if I write that the molecular pressure is higher?
You don't want to talk about the molecular pressure. You want to talk about the molecules colliding with the wall and the pressure exerted on the wall. We don't want to talk.
So what about they collide with each other more frequently?
That one's fine. So that one is frequency. We call it frequency of collision. Frequency of collision increases. Okay. So molecules collide with walls, frequency of collision increases. Okay. And this.
So I wrote the higher the momentum, the more the particles will collide with each other and causing the overall pressure to be high.
Okay, before you connect that to pressure, you must say when the molecules collide with the wall, they are not creating pressure. They are not using pressure. They are using force. So force is the one that increases. Now, how do I relate force to pressure? Because they want for pressure.
So I said the more often they collide with themselves and the cylinder, because of this collision, that's it, therefore increasing the pressure exerted on the walls.
No, that's correct. But when they collide, there is force. How pressure comes into play is because pressure
is a type of force, right? No, we should use the formula pressure equals force over area.
So you have to mention this. Since pressure is force over area.
Wait, let me just write that down.
Yeah. Since pressure is force over area and force is increasing.
And the area is decreasing. There's a higher force. Then there's a higher pressure.
Force is increasing over the surface area. As the area decreases, because the piston is being pushed what? Pressure is high. So you have to equate the force to the area, and then only you can come up with pressure. Pressure is high. Pressure exerted on the wall is high. Sureka, okay? Sureka, are you okay?
Yeah, sure.
Celeste, okay? Kamishka, okay?
So you can choose the board, actually, the points.
Yes, sure, I'm okay.
Okay.
Let me just copy that down.
Yes, can. Judith, okay?
Yes, sir.
Isabel?
Okay, sure.
Sure, is this type of question coming on the exam?
Yeah, should be. Yeah, just a moment. Okay, let's look at the next one. The next question. Let me just have a look at the question. The piston is pushed into the cylinder, the volume decreases from 820 to 330. Now, based on common sense, when the volume decreases, what happens to the pressure?
It increases.
Because now there's lesser space, so the molecules are bouncing off even faster. It's like when I put you in a very closed area, you get really agitated. It's that kind of a thing. So the pressure increases when the volume decreases. Okay? The pressure gauge measures the pressure after compression as 20,000. The temperature remains constant. Calculate the value of the pressure before the gas was compressed. So how do we do that? You can use simple ratio. Okay, so let's see, from 820, it went down to 330. And then I have the pressure at the end was 20,000. Okay. So, what do you all get?
So I didn't do this question, sir. I didn't know how to do.
So I think I know how to do. We can use the formula for pressure.
Yeah.
So 20,000 equals 820 over the. He has to find the force, right?
They asked to find the pressure before compression.
Oh, okay. That means he has to do something with calculating the difference, right?
Yeah. Or did you all learn the formula for pressure and volume last year?
No?
No? So pressure times volume gives me a constant. Basically, pressure before equals to pressure times volume before equals to pressure times volume after. So pressure before is 820, volume before we don't know. Pressure before we don't know, we want to calculate. Volume before was 820. Pressure after was 20,000. My volume is 330. So I calculate what my pressure is. Did you all learn this last year?
No.
No.
So you should get that. So pressure times volume before. Before equals to pressure and volume of after. And I just put the values in, I should get pressure before compression. Okay, so what do you all get?
8,480.7, no, 0.8, if you round it off.
Yeah. And then your unit is Pascal, PA.
So for water, what is the, if you calculate pressure for water, what's the unit?
You can use PA also, or you can, so for liquid is H rho G. So you can use PA because that's the formula for pressure, a unit for pressure. Or let's say height times density is kg over m³ times gravitational acceleration is m over s. Kg over ms. Either this or this lah. Either Pascal.
So what's the answer for the pressure thing again?
The C has
8,048.78. Okay, anyone has any questions?
Yeah, so you still haven't gotten the date when you're going to send us the question.
Sorry?
You still haven't gotten the date of when you're going to send us the questions.
The date? No,
Yeah.
it's written in the email. What's written in the email?
I'm not sure, sir.
You have to check the email. I think it's stated in your email.
Okay.
No, sir. It is in the email.
I think there is a mention of something in the email.
It said that you give it a week before.
Then a week before lah. Okay, anyone has any other questions? No? Yes?
No, sir.
Sure, will the exam be this hard, sir, to find out all the stuff?
Don't stress, don't stress. Nothing to stress about.
I'm especially worried for your maths paper. Sir.
Yeah, sure. I'm worried for maths and physics only.
Yeah.
It's not difficult. If you understand the concepts, you will be fine.
But your papers among all is the one that scares me the most. Sir.
Exactly, sir.
if I did
Don't be scared. Oh yeah, next week your exam is on a Friday, right?
cover
Yeah, sir.
almost immediately
Class. So next Tuesday, we will do 1 hour of physics and 1 hour of maths.
Okay, sir. Okay, sir.
Okay, if you're
Sir, the meeting info, right? We use the old one only, right? There's no new one, right? Okay, sir. So for all subjects or yours subjects only?
All subjects the same.
Okay, sir.
Okay, if you all have no questions, then we will end here today, lah. Okay?
Okay.
Sure. For study skills, this week we have to present to you our project, right?
Yes, yes.
Okay, sir.
Class.
Bye, Chur. Thank you, Miss
Bye,
Shweta.
Miss
Sure.
Sharina. Bye.
Bye, sir.
Thank
Bye,
you,
sir.
Miss Shweta.